All right, guys, so before we get started, are there questions over the homework? Yes. 73113. Okay. .41. Problem number 13. 731. Okay. Okay. Let's look at 731. Let's actually grab here. 7.3. 731, number 13. So we have x squared times x minus 4 over x minus 3 times x plus 3 times x plus 6 over x cubed. Yes? Is this the one you're wanting? Okay. So, luckily for us here, they did most of the multiplication for us, or most of the factoring already, because we don't have any quadratics. Guys, focus in. We don't have any quadratics or anything that we need to factor, because everything on top and bottom of both fractions are already factored. So we can go on and multiply together. So on the top we'll have x squared, we'll have the x minus 4, we'll have the x plus 3, and we will have x plus 6. Make sure I wrote that right. Nope, because that should be minus. On bottom, we have x cubed, and x minus 3 are the only things we have. So from here, we just multiply together, so we put everything on top, on the same part of the fraction, same thing for the bottom. Now our x minus 3, and this again should be minus, is going to cancel out. So our x minus 3 over x minus 3 will cancel, and that's the only set of like terms we have there. But we also have the x squared and x cubed. Because when we divide like bases here, we're going to subtract the exponents. So 3 minus 2 is 1. Since it's bigger on bottom, it will stay on bottom. And that's actually the only thing we have left. X minus 4 times x plus 6 over x. Questions on this here? You got a question on 7412? Yeah. 401. Number 11. Let's look at that one there. So number 11 wanted us to find the least common multiple of 2x and 2x times. Okay, yeah. Okay. Yeah, because the least common multiple for this here ends up being 2x times x minus 5. Yeah. Okay. 741, 12. So we're still finding the least common multiple. We have 24x squared and 8x squared minus 16x. Now the first thing we want to do to find the least common multiple is factor both of these expressions as far as possible. Now the 24x squared, since it's a single term, it's factored as far as it'll go. Now we look at the other expression, 8x squared minus 16x. Again, the first thing we need to look for is the greatest common factor amongst these terms. Now, the greatest common factor, the biggest number that will go into both 8 and 16 is going to be 8. Because if we factor 8 out of 8, it factors completely. And if I factor 8 out of 16, 16 divided by 8 is going to be 2. Now, x squared and x, they also do have a greatest common factor of x. So when we fully factor, so 8x out of 8x squared, we're left with x. When I factor 8x out of 16x, 16 divided by 8 is 2. The x factors out completely, giving us 8x times x minus 2. Now that they're factored completely, we can actually start looking at the least common multiple. Now, it doesn't matter where we start with least common multiple. We can start with our parentheses terms, these expressions, or the terms outside. If we start with the parentheses, the one on the right has an x minus 2. The one on the left doesn't. So since x minus 2 as an expression shows up once, in either one of these, we will need it once as a part of the least common multiple. Now we go outside. We do have x and 8. We have 24 and x squared. Let's start with the variables first. The one on the right has x one time. The one on the left has it twice, so we will need it twice. We'll need 2 of them, x squared. Because those are nice, we can see them, we can see the factors. Now we need to figure out what is the first number, the least common multiple between 8 and 24. Now we can do this in one of two methods. First method is that we factor down 8 and 24, look at the common factors and go from there. And to do that, 8 is 2 times 4. 4 is 2 times 2, telling us that 8 is going to be 2 times 2 times 2. We'll do the same thing with 24. 24 is 2 times 12. 12 is 2 times 6. 6 is 2 times 3. So 2 times 2 times 2 times 3. And from here we can get our numbers. Because we're looking for which one has the most factors of each factor. And that many factors we will use as a part of the least common multiple. So if we look at the factors of 2, 8 has how many factors of 2? 3. 24 has how many factors of 2? So we will need 3 of them. Now we'll look at the only other factor. So 24 has one factor of 3. 8 has 0, so we'll need 3 one time. So it gives us 2 times 2 times 2 times 3 times x squared times x minus 2. But those numbers we can simplify because our 2 times 2 times 2 is 8, and 8 times 3 is 24x squared times x minus 2 is the least common multiple. It's not always going to work out that the least common multiple, the number outside the parentheses, is going to be the same as one of the two. It can be, or it's going to be bigger. Questions on these here? Okay. What we're looking at today is simplifying complex fractions. Now we define something to be a complex fraction if we have a fraction on top and bottom, or more than one. So a simpler example of this is 7/2 over 3/4 would be considered a complex fraction because we have fractions inside of the fraction. We have fractions inside of fractions. Now we can't leave it in this form. We do have to simplify. Now there's two methods to simplify. One, if necessary, simplify the numerator and denominator, writing them as a single fraction, and then dividing by multiplying the numerator by the reciprocal of the denominator and simplify as far as possible. Or we can multiply the numerator and denominator by the least common denominator of the fraction and then simplify. So we're going to look at both of those methods because, yes, that's a lot of words that's trying to figure out what it's saying, what we're trying to do. Now, when we look at this here, we're going to do it by method 1. Method 1 says I want one fraction on top and I want one on bottom. And as we look at this first one here, the numerator, 5 over x plus 4, is one fraction. We have a single fraction on top, so we're good there. As we look at the denominator, the bottom of this fraction, we have 2. We have the 1 over x plus 4 plus 2 over x. We actually have 2 fractions on the bottom. And we want to be able to make that, or we want to rewrite that as a single fraction. Because if we can write it as a single fraction, we can actually divide these here. All I'm doing is just rewriting it so it looks a little bit nicer. Now, for us to be able to add those 2 fractions on bottom, we need the denominators to be the same. So we need to look for the least common denominator. The first expression that's going to make the denominators be the same. And whenever we find that, we're going to multiply both of these fractions on top and bottom by whatever they're missing to get the denominators to be the same. And this is kind of nice, and I say that because the one on the left denominator is only x plus 4. Nothing to factor, nothing to do with simplifying it. The one on the right is just x, so there's nothing to factor there. I also think it's nice because if we look at this here, what is the left one missing that the right one has? Well, it just has that, almost, because it's just missing the third times the charm, x. Because yes, the one on the left does have x, but unfortunately, x and x plus 4 are considered 2 separate expressions because of the plus. Now, if the one on the left had been 4x, 4 times x instead of x plus 4, yes, they would be the same. But because of that plus, x plus 4 and x are not the same. Questions on that there? So to make the denominators be the same, we're going to have to multiply the left side by x over x, which means the right side, this x is missing what? X plus 4. So we're going to have to multiply it by x plus 4 on top and bottom. Now the numerator is still 5 over, 5 over x plus 4. Now the denominator, the one on the left, we're going to have to multiply 1 and x on top. X times 1 is, well, x. On bottom, again, just like when we did addition and subtraction on Friday and most of last week, we're going to leave it the same. We're not going to multiply through. We're just going to leave it as x times x plus 4. Plus. The same thing is true with our other denominator. Our x times x plus 4 is going to stay x times x plus 4. And just like with adding or subtracting fractions, we're going to have to multiply the numerator because if there are like terms, we're going to have to add or subtract. So leaving it in factored form does not help. Now our 2 times x is 2x. 2 times 4 is 8. Questions on how we got to this point here? Hopefully you're noticing this is very similar to what we did Friday and most of last week, or Thursday and most of last week, but instead of having just that one expression, it's just looking at the bottom of the fraction. Same thing. Because now at this point, because the denominators are the same, we can add the numerators. Now normally we would write them with parentheses, but because there is no sign change, we're not subtracting, there's really with or without the parentheses for this one here is not going to make a big difference. Because we're still going to be able to go from here and say that x plus 2x is 3x. It doesn't have any like terms, so the numerator of the denominator is going to be 3x plus 8. Over x times x plus 4. Questions on this here? So we've done what we wanted to do. We wanted to get one fraction on top and one fraction on bottom. Now we can't leave it in this form because we cannot have fractions inside of fractions. That does not work. We cannot leave it that way. But really what a fraction is telling me is that it's really the numerator divided by the denominators, the top divided by the bottom. So another way to look at this is that we have 5 over x plus 4 divided by 3x plus 8 over x times x plus 4. We have to rewrite it as division to be able to get this fraction to simplify further. But to simplify a division of two rational expressions, we keep the first one the same. We change it from division to multiplication and flip the second. Telling us that we have 5 over x plus 4 times x plus 4 over 3x plus 8. At this point here, we can multiply the numerators. 5 times x plus 4 is going to be 5x times x plus 4. And on bottom, we have 3x plus 8 times our x plus 4. Now, the order in which we have that product really doesn't matter. I only put the 3x plus 8 first because I started writing it first. No other reason. Questions on how we got here? Now, there is something in common on top and bottom. Yes? And it is the x plus 4 over x plus 4. Telling us that we have 5x over 3x plus 8. Now, we don't necessarily need the parentheses around the 3x plus 8 because there's nothing else on bottom with it. But that 3x plus 8, the 3x and 8 are stuck together because it's a plus, so we can't simplify it with the 5x on top. If it had been 3x times 8, or we had some product or way to get 3x or an x out front, then we could simplify. 3x and 8 do not have any common factors between them, so there's no way to factor that. But the simplified version of this here is 5x over 3x plus 8. Questions on this here? So that's method 1. For the most part, I don't think y'all have a lot of extra room. Took up most of the paper, yes? Now you should have, I think, a little bit of extra space above example 1 and below that explanation there. I want to show y'all method 2, looking at this again. Yep, so right above the problem, underneath this here should be some extra space, and it's going to be more than enough. We're actually going to write it out this time, least common denominator. I want to look at the least common denominator of this fraction. And we're specifically looking at the individual fractions on top and bottom of this expression. So I'm not looking at the whole denominator of the 1 over x plus 4 plus this whole thing here. We're not looking at that. Specifically, what we're going to look at, get a highlighter, are the denominators of the numerator and denominators. So we're looking at x plus 4, and x, and we want to figure out what the least common denominator of these three fractions are. And as we look at the top denominator, the numerators, denominator, x plus 4 shows up once. Yes? If we look at the bottom two, the first one, x plus 4, shows up once, and the other one we have an x one time. So x plus 4 does show up in two different places, but how many times does it show up in each one of those? Once. So a part of the least common denominator, we will need x plus 4, but we will only need it once. Even though it does show up in two different locations, we only need it once because it only shows up in each of those locations one time. Is there any other expression that we're missing so far? Because that takes care of these two here, yes? But we also need an x as a part of the least common denominator. So as we look at the numerator and denominators, the whole fraction, the bottoms of the numerators, the denominators of the numerator, and the denominators of the denominator, the least common denominator of all of this is x times x plus 4. Questions on how we found this expression? Now what we're going to do, I'm going to rewrite this off to the side. 5 over x plus 4 over 1 over x plus 4 plus 2 over x. What I'm going to do is we're going to multiply the numerator and denominator, the top and bottom, the whole numerator and the whole denominator by this least common denominator. Now this seems a little weird and kind of strange we're doing this, but let's see what happens. Because we multiply by the numerator, so we're going to take that x times x plus 4 and multiply it by each fraction on top of the fraction. So what we're saying that we're doing is we're taking this expression, 5 over x plus 4, and multiplying it by our x times x plus 4. We're going to multiply it by that fraction. Questions? We're going to have to do the same thing on bottom. So the x times x plus 4 is going to be multiplying by this 1 over x plus 4. Plus, we're also going to have to multiply it by our 2 over x. Now, we're not going to specifically write it out this way every single time. I'm writing it this way so we see what we're multiplying, what's happening. Questions on how we got here? I know there's a lot written, but it's going to simplify actually very quickly here in a second. Now with the numerator, with this expression here, when I multiply a fraction by an expression without a denominator, we know that the other's expression's denominator is 1. We multiply top with top, bottom with bottom. So the 5 and the x times x plus 4 are going to multiply together. Now our 5 times x is going to be, well, 5x. And we'll still have our x plus 4. On bottom, the denominators, our x plus 4 times 1 is going to give us x plus 4. So by multiplying x times x plus 4 by our numerator, gave us 5x times x plus 4 over x plus 4. Well, wait, we have something in common on top and bottom, yes? So those x plus 4 over x plus 4 would simplify. Do we have a fraction on top anymore? No. Let's look at the denominator and see if it does a similar thing. Now the first fraction, the 1 over x plus 4 times x plus 4, again, just like the top is over 1. So our numerator, 1 times x plus 4, is just going to be x times x plus 4 over 1 times x plus 4, just x plus 4. Plus, our last fraction, we're going to do the same thing. Our 2 times x plus 4 is going to be 2x times x plus 4. X times 1 is x. And just like the numerator, as we look at the bottom of this fraction, the x plus 4 and x plus 4 would cancel. The 2x times x plus 4 over x, well, the x over x, we have one x on top and bottom, they would simplify out completely. And what that leaves us with is, on top, the numerator's only fraction is going to be 5x over 1, or just 5x. On bottom, our first fraction simplifies to x, and our other one's going to be plus 2 times x plus 4. So by multiplying by that least common denominator, we're able to simplify the fractions out of the top and bottom, giving us this here. So the only thing we have left to do is simplify that denominator, combine like terms, because the numerator 5x is just 5x. On bottom we have the x, but we do need to distribute this 2. 2 times x is 2x, 2 times 4 is 8. Now that does give us some like terms on bottom. Our x plus 2x is 3x. 3x plus 8 does not have anything in common. There's nothing we can do to simplify, telling us that we get 5x over 3x plus 8. Questions on this here? The second method is a lot less steps. We added a few for this one here just so we can see how that product worked, how that multiplication worked. Yes. But if we're able to find that least common denominator, multiply it through, we can simplify these fractions out a lot faster. Questions on this here? We good? So let's look at this next one here. We want to simplify 6 over x minus 2 over 1 over x minus 2 plus 3 over x. Now, if we do this by the second method, we need to figure out what we need to multiply the top and bottom of this fraction by so that the fractions on top and bottom, the numerator and denominator, would simplify. Now, the first thing we need to do is make sure each of these expressions on the denominators of the numerator and denominator are factored as far as possible. So the numerator's denominator, x minus 2, is as simplified as it gets, because x and 2 do not have a greatest common factor. The degree is 1, so it's good there. Same is true for the x minus 2 on the fraction on bottom. And the only other expression in the denominator is x. It's a single term, so it is simplified. So what's one expression, or one part of the expression we need to multiply everything by? So what's one of the things that we need as a part of the least common denominator, what we need to multiply everything by? X and x minus 2. Now we need x minus 2, especially on top, to simplify with this x minus 2. Now, even though it does show up again on bottom, but in each of those denominators, it only shows up once. So we only need it once. If the top or bottom, one of them had x minus 2 squared, it had it 2 times. Since it shows up twice in one of the spots, we need it twice. But here, it only shows up once in any of the spots. Now, we also have and x. And since it only shows up in that one denominator once, specifically that one spot, it shows up once. We're going to need it once. Questions on how we found this least common denominator, or what to multiply by? Now we're going to multiply this on top and bottom each of the fractions, yes? And when we do this, we're taking this whole expression and we're going to multiply it by each numerator. Each numerator in the numerator and denominator. So for our top fraction, that x times x minus 2 is going to be multiplied by the 6. So on top, we're going to have 6 times x times our x minus 2 over x minus 2. And we're going to do the same thing with the denominator. We're going to multiply this x times x minus 2 first by our 1. And 1 times x is going to be x. That wrote plus minus 2 over our x minus 2 plus the x times x minus 2 is going to multiply by the 3. And 3 times x is going to be 3x times x minus 2 over x. Questions on how our product, multiplying the top and bottom by x times x minus 2, got us here? We can simplify on top and bottom. In the numerator, the x minus 2 over x minus 2 will simplify. In the denominator, the first fraction, the x minus 2 over x minus 2 will simplify. In our last fraction, we do have that 3x out front being multiplied with the x minus 2. So that x on top and x on bottom, we have 1 and 1. They will simplify out completely. And again, this is nice because the numerator, we do have the 6x, but because the denominator simplified out completely, they put it over 1, we don't have a fraction on top anymore. On bottom, the first fraction just reduces to x. And our second fraction, we still have the 3 outside, and the x minus 2 telling us that it's 3 times x minus 2. Questions on this here? Now we can say this is simplified as long as like terms, everything's been factored and reduced. Now we can't say it's finished because there are x terms, possibly like terms. Since we have this 3 times x minus 2, we do have to multiply it out. Now our 3 times x is going to be 3x. 3 times negative 2 is negative 6. Questions on this here? Good? Fly somewhere? Now we need to combine like terms because our x plus 3x is 4x minus 6. So distributing that 3 did give us some like terms we had to add and subtract. Here we had to add the x and 3x. Give me a 6x over 4x minus 6. Questions on how we got here? Yes. Sure. Mm-hmm. Now, where we're at, really last thing we need to look at is see if we can factor. If we can factor our final statement any further, we're going to need to. So as we look at the top and bottom of this final part here, the numerator is 6x. It is one term, yes? So there's no way to factor 6x any further because it's a single term. The denominator, 4x minus 6. Now the degree is 1 because we only have x or x to the first. So our normal 2 sets of parentheses with 3 spaces isn't going to work. So the only thing we could do there is find a greatest common factor. Is there a number that can divide into both 4x and 6? 2, yes? So on the denominator, on the bottom of this fraction, there is a greatest common factor of 2. Now it's not going to be 2x, because 4x does have that variable x, but 6 does not. So we can't take out a variable. But we can take out the factor of 2. 4x divided by 2 is 4x divided by 2 is going to be 2x minus 3. Because when I divide 6 by 2, we factor that out, we get 3. Yes, it would. I just forgot to write it. The x would be on top with the 6 still. Questions on how we got here? Now, factoring the top and bottom, even if nothing reduces, we're going to need to do it just in case something would. Because now on bottom, we have two things being multiplied together. We have the 2 times our 2x minus 3. On top, we have the 6 and x. Since there is a product on top, this 6 over 2 is going to reduce. Because 6 divided by 2 is 3. So the 6 on top would reduce to 3. Because we have 3 times x, we have that product. It can simplify. On bottom, the 2 factors out completely. So the 2 outside the parentheses, not our 2 next to the x, giving us 3x over 2x minus 3. So there was a common factor of 2 that had to be reduced at the end. Questions on this here? You're good. So what part?
I was wondering how are you factoring out the 6 from the 2 from being on the bottom?
So this 2 here, or going from here to here? So, go back. There we go. So we're good to here, yes? So what we can say really is that we actually have 2 fractions being multiplied. Because the numerator is 2 terms being multiplied together. We have 6 times x. On bottom, we actually have 2 expressions being multiplied. We have the 2 and the 2x minus 3. Because when we multiply 2 fractions, we multiply top with top and bottom with bottom. So from here, our 6 over 2 would reduce to 3 over 1. Giving us 3x over 2x minus 3. Because the numerator, the 6 and x were being multiplied, and the 2 and that 2x minus 3, we can split it and reduce. Questions on this here? I think you saw it as soon as we started breaking it back apart, yes? Yeah. Any other questions? Guys, let's look at this here. X over 6 minus x over 3 all over x minus 5 minus 7 over 10. Now again, we want to do the same thing. Even though we're looking at 4 numbers, we're not looking at 4 expressions, it still works the exact same. If we can find the least common denominator, the first number that we can turn 6, 3, 5, and 10 into, we can see what we need to multiply the top and bottom of this expression by to get the fractions to go away. Now the 2 denominators we have on top, one of them is 3 and the other is 6. On bottom we have 5 and we have 10. 3 and 5 are prime. There is no way to factor them down. There is no simpler form of it. It's just 3 and 5. 6 factors 2, 2 and 3. 5 is 2 and 10. So we start listing the factors of this here. It doesn't matter which order we go into or which factors we look at first. I'm going to look at 2 first. 3 does not have any factors at 2. 6 has 1. 5 has 0, and 10 has 1, 2. So we need 2 listed ones. We can do the same thing with 3. In all the spots, 3 only shows up once. I don't know, right? I just realized I wrote 10. But that should be 5. And lastly, 5 only shows up once. So really the least common denominator is going to be between 2 times 3 times 5. 2 times 3 is 6, and 6 times 5 is 30. So the least common denominator, yes. There are 2 2's, yes. But how many does each 2 show up in each of the expressions? Once, so we only need it once. Yes. It does show up twice, but since it only shows up once in each of the terms, we only need it once. So that means we can multiply the top and bottom of this expression by 30 over 30. And as we do this product, again, we're going to multiply numerators on top by 30. So our 30 times x is going to be 30x. It's over 6. Minus 30 times x is 30x over 3. On bottom, we're going to do the same thing. 30 times x is going to give us 30x over 5. Minus 30 times 7 is going to give us 210 over 10. So we're going to do that distributing. We're going to multiply through by 30, and then we're going to reduce. Because as we look at each one of these here, 30x over 6, 30 divided by 6 is going to give us 5, and we still have our x. Minus 30x divided by 3, 30 divided by 3 is 10, and we have our x. 30x over 5 would be 6x. You guys stay seated. We're finishing this. And 210 divided by 10 is going to be 21. Now, the numerators do have a like term. The 5x and 10x are like terms. So 5x minus 10x is going to be negative 5x. The denominator has a greatest common factor of 3. So when we factor it out, we get to this point here, and that is simplified as it gets. We'll finish this tomorrow.